Hi, my name is Jamie Ayton. I'm a food chemist with the Department of Primary Industries in Wagga Wagga in New South Wales. I was just going to start by thanking Michael Houlihan for introducing me to the club. Michael sent some samples to us after we did a little news article about our project, and thanks to Barry also for organising the Zoom meeting tonight. So I'll get straight into it. I thought I'd talk a bit about myself to begin with. So I've been with the department since 1995. I've got a bachelor's degree in science. I did a master's degree through the University of Western Sydney when we were doing the olive work. So most of my career has been as an edible oils chemist, mainly olive and canola oil. We also look at sunflower, safflower, all the oil producing plants. We've recently got into some quality analysis of meat. So we've got meat, beef and sheep researchers within the department. So we're looking at some quality components in that. And honey that we're talking about tonight. We've got NATA accreditation in our labs. So we follow all the rules and regulations that ISO 17025 require us to. So we're audited. We have a major audit every 3 years and a surveillance audit every 18 months in between. And that's basically, we do what we say and we say what we do, and we have to keep records of all calibrations and things like that. We do adulteration testing on olive oil. We're accredited by the International Olive Council and the American Oil Chemist Society to do that. And the reason I bring that up is that's part of the reason why we've got into honey research. So there were some issues a couple of years ago that you're probably all aware of, where there was some talk around the traps that some honey in Australia was not authentic. And I think they just wanted some fresh eyes on that from someone that had been involved with a similar product. And if you think about olive oil and honey, they are very similar. They're both raw products. They both have health attributes, and people like to use those natural products that they aren't processed in any way other than a bit of heat applied maybe. Because of that, they also are open to adulteration. And I think of the top 5 adulterated foods in the world, both olive oil and honey are at the top of that list. I'm on a few technical committees, just so Standards Australia, I'm on the Edible Oils Committee for standards there, on the technical committee for the Australian Oilseeds Federation, and I've just joined the United States Pharmacopoeia Technical Committee for Oils, and I'll probably go on to the Honey Committee next year. My first involvement with honey was back in, I think it was 2018. We were approached by AgriFutures to do a literature review on chemistry, and I won't talk too much about that, but there is a link there. If you just go to the AgriFutures webpage and look that up, and it's free to download as a PDF if that's something you're interested in. So the objectives of this project: establishment of a database on the composition of honey. Why are we doing that? So when there is any criticism of the industry, we've got scientific data to back up any points we're trying to make. So it might surprise some of you, but the last time a comprehensive study was done of the chemistry of honey in Australia was in the mid-70s. And as you can imagine, things have changed since then in terms of the equipment that's available to measure some of these things. So in terms of food defense, we will have scientific data. At the end of this project, we'll have scientific data to back up any claims we're making about the product. As with olive oil, we might look at the development of an Australian standard, but when we first started looking at the chemistry of olive oil, we realized that local conditions meant that we were producing a slightly different product than the traditional European product. So we actually developed an Australian standard for olive oil. I'm not saying the same thing will happen for honey, but we need that information to know what the thresholds or what the ranges are of the different things we're about to talk about in Australian honey. And then the industry can use that to develop a strategic plan for the future. Here we're very clear about the analytical methods that we want to use. If any of you guys are involved in research, you would know that there's 1,000 different ways to do some analysis. Sugar analysis is a perfect example. There's just so many different ways, but they produce slightly different results. So we're really keen to look at the international standards for honey and develop methods along those lines. So anything we did here was comparable in an international forum, so we could defend our product if needed. And we want both growers or beekeepers and consumers to be confident that the product that they're getting is a high quality product. And the only way to do that, again, is with scientific data. So the official title of the project is Composition of Australian Honey. So AgriFutures provides about half the funding, and New South Wales DPI the remainder. So in summary, I'll just go through the steps and where we're up to. So the first thing we did was develop, validated and verified those standard analytical methods. A big thing in our lab is we participate in the international proficiency program. So I've been doing these for more than 20 years with all the different products we test. So as I mentioned before, we're accredited by the International Olive Council, the American Oil Chemist Society for the olive oil. So one of the first jobs when we started testing honey was to look for a proficiency program to ensure we were able to do the tests accurately and efficiently. So we undertake the FAPAS program. So that's an acronym, FAPAS. So we pay a fair bit of money every year, or not every year. It's 4 times a year. A sample is sent from a central location to labs all over the world. We all test it, send our results back, and compare our results to the main just to see how we're going. The collection of the honey has been interesting. I've written, it was an initial 2-year timeline for this project. COVID created havoc pretty much as it has for everybody else, I imagine. So we have got an extension. So we're going well into next year with this project. We will do the testing and give individual reports to everybody that contributes a sample. And we're going to do a summary of all the data and the trends in newsletters, scientific journals, conferences, wherever we can. At the end of the project, everybody who's contributed will probably get a PDF of the final report as well, and it'll be available on the AgriFutures website. With every product that we work with, we end up developing a testing service on a fee-for-service model. So with the olive oil, the canola, the meat, we've got an animal feed lab next door. So they measure stuff in hay and grains and whatever. The only thing we need to do is recoup the money. So it's non-profit. We price our tests so that we can pay for our salaries and consumables. So sample collection, we can, anybody who wants to participate, we can send out a little kit. The kit has a plastic collection jar for you to provide your sample. So all you need to do is let us know you're interested in participating. We ask you for some data about samples, so I won't go through all of those, but you only need to tell us what you know. Some people have very specific floral sources because their hives are in the middle of a red gum forest. Others say it's just a backyard operation of 2 or 3 hives, and we don't know what the floral source is. We'd like to know the extraction conditions, and some of those other things, just so if we do find anything highly unusual, then we can contact the beekeeper and see what's different, what's particularly different about that sample. But rest assured, all our data is kept confidential. We won't give that to anybody else. The only time it will appear will be on an individual report to yourself, and we're bound by the AgriFutures privacy and New South Wales DPI privacy regulations around that. So enough about that. What's the analysis we do? Start with moisture. So we measure moisture with a digital refractometer. Some of you have probably have access to a handheld refractometer. The only difference is ours is looks like a microscope. There's my big shiny head looking down into it there. It's a bit more expensive than your handheld refractometer, and we can correct it. It's got an internal thermometer, so we can correct our moisture back to 20 degrees. So it's all standardized. Moisture is affected by the floral source and the maturation or the maturity of the oil. And as you guys know, I don't pretend to know a lot about the art of beekeeping. It's all fairly new to me, but as you guys know, the extraction and processing and storage can have an effect on moisture. It's important because if the moisture is very low, it makes the product fairly difficult to handle and process. And if it's high, you'll get fermentation occurring. It does have some effect on the physical properties of the honey. And I've just included the International Codex. For those of you who don't know what Codex is, it's an international standards organization that has standards for a lot of different types of food. And at the moment, the Australian standard, I didn't include it in any of the slides, but the Australian standard makes me laugh every time I think of it, because the Australian standard says A, the product must be honey, and B, the sugars must be above 60% and moisture below 20. So there's a few decisions to be made down the track based on this database, whether we're going to update that standard or not. The next thing we measure is free acidity. That's my technical officer, Leanne Groves there, doing some acidity measurements. We measure the pH first, and then we titrate it with sodium hydroxide to a certain point. Free acidity is affected by the floral source. And it's because you get these acids that are in both the nectar and the bee secretions. And we can tell a bit about the age of the honey when we look at free acidity. So if it's high, there's a bit of fermentation going on. That's because of the degradation of the sugars, as I've noted there. And the Codex limit for free acidity is it should be less than 50 milliequivalents per kilogram. Sugars, I'm not sure how technical you guys are, so I'm sorry if some of these acronyms are a bit too much, but we use an instrument in the lab that's in behind Leanne and myself there, that's called a HPLC, or a high performance liquid chromatograph, and we've got a thing called a refractive index detector on that, and we can measure really accurately fructose, glucose and sucrose. We could measure other sugars, but anybody that knows carbohydrate analysis knows that it gets really complex really quickly. So we're focusing on those three because they're the three that have an international limit, And they're also in those proficiency programs I was speaking about. So we know how accurately we can measure those 3 sugars. Again, it's affected by floral source. If sucrose is high, it can mean a couple of things. Early extraction, so the sucrose hasn't broken down into fructose and glucose yet. If you've had excessive supplementary feeding, if you've had the sugar water on top of your hives and some of it's somehow got through into the honey, we can see that in the sucrose result. It's important because of the physical and nutritional properties it brings to the honey. There is an adulteration aspect there, that if there's some adulteration occurring, some of these things can, especially the sucrose, can exceed the limit, but it's not the best. It's not the best and only way to determine adulteration. That's why I left it off the list there. The Codex limit is for fructose. The sum of fructose and glucose should be greater than 60 grams per 100 grams of honey, and the sucrose should be less than 5 grams per 100 grams. HMF is the next thing we measure. An organic compound known as 5-hydroxymethylfurfuryl, or HMF, is formed by reducing sugars in honey and various processed foods in acidic environments when they're heated through the Maillard reaction. This is the normal reaction I get when I say something like that. Unless you're fairly technical, that's all gobbledygook, really. So all you have to know is that HMF is formed from the degradation of sugars, and that happens with heat or over time. So how do we measure it? We use that same instrument I mentioned before, the high performance liquid chromatograph with a photodiode array detector. Like I said, if your sample is heated or just naturally over time, those sugars start to degrade, HMF will increase. And I can give you a real world example of this. Someone had a breakdown in their processing plant. So they sent us 4 or 5 honeys and they were all well below 40 milligrams per kilogram, which is a Codex limit. They're probably, none of them are higher than 20. The honey that was being processed when they had their breakdown, with a lot of heat went into the honey in a very short period of time, the HMF was over 300 when we measured it. So that's an indicator of so that even heat during storage. So if you're storing your honey, in the back shed that gets up to 40 degrees in the summer, you're probably going to see HMF increase more rapidly than if it was in a cooler environment. The next thing we measure is the diastase number. So diastase is an enzyme, the amylase enzyme, and it's secreted by the bee when it's regurgitating the nectar into the hive. So as it's regurgitating, some of this enzyme is transferred. So we measure it using something called the Fadibus method, which is just a name given to the particular method. And so we add various chemicals. There's a color that's produced that's dependent on the amount of enzyme in the honey. And then we can tell you fairly accurately how much diastase is in there. It's very stable in a stable storage environment. However, as I've said there, it's affected by time and heat. So over time, it will decrease naturally. If the sample's subjected to any sort of heat, either during processing or storage, it will decrease as well. So it's an indicator of honey. The Codex limit says it should be greater than 8, and the unit's called shade units. So you're looking for a number greater than 8, and using that same example of the HMF, that was accidentally overheated. Sorry, the sample was accidentally overheated, and the HMF was over 300 for that sample. For that same sample, the diastase number was less than 2. It was actually below our quantification limit. So you can see the effect of that type of thing on the diastase number. We measure water insoluble solids. We've got a porous crucible. We weigh the sample and then pass it through that crucible with 80-degree distilled water. And I don't know if you can see my my arrow, but so we're pouring the honey solution through there and filtering it through with this pump. And we collect basically all the debris. So as I've said there, honeycomb, pollen, bee parts, dust. This will be an interesting one for the industry, I think, because as you guys know, some people filter their honey, others don't. So there might have to be a filtered honey limit versus an unfiltered honey limit, because obviously unfiltered will probably have more of those different types of things, and some of it you can't control. You know, if you have a dust storm go through that and you're not filtering, that's obviously going to have an impact on your final product. I thought it would be good to show you what a report looks like. So I took this report, I've removed, so you get a cover page with any information you've provided. I've removed some stuff from this page just so there's no identification there, but that's the actual results. So you can see there we give the result for the sample you've sent in, the units, and then the Codex standard limit when there's one available. So that's what you'll be getting when you contribute. So as I think I mentioned this before, but we'll establish this database. You'll get your report, but then we'll use all that information in the database. No one else will see any of the details that you provide other than a summary of the data. And once we have the database completed, we're going to use as many pathways as we can to get that information out, just so everyone's clear about the ranges for all these different things we're measuring for honey. So what are our next steps? We want to continue to collect samples. So if you or anyone you know would like to be involved, please do contact us, and we'd be more than happy to take sample. We can send you out the container. We've got a reply paid code, so it doesn't cost you anything to send your sample back to us. You'll get that an individual report like the one I just showed you. You keep an eye out for whether as you've noticed, I haven't been able to give you any data yet, and that's simply because we don't think we have enough data in the database to start publishing anything yet, but it's going to happen really soon. We've had an influx of samples since Christmas. And as I said, we'll be reporting all of this stuff in as many different forums as we can. And this time next year, we'll be wrapping this up. So I'd be more than happy to join you guys again and talk about the final results. It'll be up to the honey industry what they want to do. They might just go with a Codex standard. Will they develop an Australian standard? I don't know. It'll be up to, I'll be part of the conversation, hopefully. But it really is up to the industry to make some decisions based on the data that we generate from this. We just had our surveillance audit for NATA. So that means in 18 months, So 18 months, probably late next year, we will get all of these methods accredited. So as soon as we go to a commercial service, if that's what the industry wants, they'll all be accredited the same as our other products. And like I said, there we'll establish the fee for service testing service model if that's what the industry is interested in. Just to finish off, there's quite a team of people that have been involved from this, developing it and providing the funding. I won't go through everyone, but yeah, just like to acknowledge everyone who's helped out with this project and thank them for their involvement.